So we left off, we looked at off of a cliff, but the key with this one was, oh, don't undo that, Mr. Dueck. The key with this question was they gave me the time right there, and as I've said to you, we spend most of our time finding time. Since we knew the time, it kind of fell apart. Let's try number 4. A projectile is launched from the ground with an initial velocity of 88 meters per second at an angle of 70 degrees with the horizontal. I'm going to draw a little picture. I think it looks an awful lot like this. 70 degrees is pretty steep. 88 meters per second. Angle of 70 degrees. Now, the fact that this is a projectile, the fact that this is slanty, even though I haven't even read part A, I'm pretty sure, Tyler, I'm going to be doing a t-table. I'm going to find the horizontal and vertical components of this slanty. I'm going to write AX equals 0. I'm going to write AY equals negative 9 point. I already know a lot of where I'm going to go. But, what's this question asking me to find? Can you read part A to me, Tyler?
What is the velocity, magnitude, and direction of the projectile
after 4.6 seconds? In other words, it's asking what the velocity is going to be, like right here, or maybe on the way up. I'm not sure. How am I going to do that? Well, you know what? Let's start. May as well do that. AX equals 0, AY equals negative 9.8. Is there a slanty velocity? Well, then I better break this into components. So we called this Vx, and we called this Vy initial. Do you want me to use the shortcut or derive it? You want me to derive it? So it's going to be opposite hypotenuse. Which trig function is going to be Vy? Sine V. Oh yeah. Anyways, if I derive it, it would be sine 70 equals Vy over 88. How would you get the Vy by itself, Rob? Okay, so this is why my stupid Vy is sine thing works. It's going to be 88 sine 70. Can I take a shortcut for Vx? Which trig function is Vx going to be? Of course it is, and I think it's going to be 88 cos. So I'm actually just going to go straight to equals 88 cos 70. And I sense that you guys don't like keeping those expressions. You prefer to have the numbers, and okay, I'm fine with that. 88 cos 70, 30.0, well, I guess 30.1, well, or 30.098, let's do that. 30.098, sure that works. 30.098, and Vy ends up being 82.693. Okay. What's this question want me to find, Ty? Now, I think what it's asking me to find, don't write this down just yet. Don't write this down just yet. It wants me to find this velocity, the slanty velocity after 4.6. The only problem is I'm not sure if I should draw it like that or if I should draw it like that. Don't write this down yet. But no matter which way I'm going to draw it, I'm going to break it up into Vx, which I know, 30.098, and Vy final. That's going to be after, was it 4.2 seconds? Is that what I said? After 4.6 seconds. Is there a way that I could figure out ahead of time whether it's on its way up or on its way down and know how to draw it? Get the total velocity. I think you thought it right. I think you may have said it. Because I would argue this is the total velocity here. And is there any way I could figure out whether I want to draw that slanty pointing upwards or pointing downwards? What's going to determine whether I'm on my way up or on my way down? total flight time. I think I can do it even quicker than that. I heard it here. No, someone said it right here. What's negative?
The velocity.
Which one?
An initial.
Which one?
Vertical.
Yes! Not initial, though. Final. You know what? If I just find what Vy is after 4.6 seconds, if it's positive, it's on the way. If it's negative, it's on the way. And I'll know how to draw it before I draw it. Is that okay? So I've really thought this question through. I'm planning my attack, and I'm going to say, you know what? Time for both of these is 4.6 seconds. And I'd like to find Vy final. And by final, what I really mean is at 4.6 seconds. Because you could argue, isn't final when it hits the ground? Yeah, but we're not interested in that right now. I'm looking for an equation that has V final. Oh, our favorite one. It's going to be V initial plus AT. It's already got the V final by itself. The final velocity is going to be 82.693 plus negative 9.8 times 4.2. What's the y velocity after 4.2? Oh, I even have this on my calculator. Not plus twice. Negative 9.8 times. I keep doing 4.2. I don't know why. For some reason, that's in my head. 4.6. Thank you. Even did it there. Oh. Is it on the way up or on the way down? Up. 37.613. So, now I'm going to dope. This is what they're asking me to find. It might be not quite so steep. It might be steeper, but I do know it's pointing up, and that's really all I want to get in the right place. And I can now say that would be broken up into Vx and Vy final. And I now know both of those. It's going to be 37.613, and it's going to be 30.098. And this is the mystery overall. This is what I would, Sophia, call total velocity. The combined Vx and Vy. That's the total velocity at that moment in time. Magnitude and direction. Oh. Pythagoras and tangent again? Yeah. And I love the fact that as tough as this is, we end up solving it with a little bit of Math 8 and a little bit of Math 10. V squared is going to be 30.098. And again, if you're comfortable doing Pythagoras all on your calculator, showing no work, in your homework, go ahead. On a test or a quiz, I'd still show my work. $30.098 squared plus, answer squared. Square root of that. And I get a magnitude of 48 oh, this is my final answer. Now I'll go to 2 sig or 3 sig figs. I'll call it 48.3. Sorry, 48.2. Round off properly, Mr. Dueck. At what angle? Where the vector is originating from, that angle there. By the way, how will I describe that direction above the horizontal? Because I can't call, I mean, again, if you said in your picture, if you called that north of east, I'd wince, I'd cringe, I'd give you the marks, Devin. But that's not, up is not north. Because we're looking at a side view. Oh, tangent. Opposite. Over. Adjacent. $37.613 divided by 30.098. 51.3 degrees? 51 degrees, but 51.3 degrees, yeah. 51.3 degrees above the horizontal. Yay! B. What is the velocity, magnitude, and direction after 12 seconds? You know what? I have a feeling it's probably on the way down. How could I figure that out?
Because you're a good test writer?
No, I mean, how could I prove that? I am a good test writer, but how could I prove that? How did we figure out that it was on its way up? Yeah.
Getting the time when the projectile is on the top.
Could do that, but I can do something even easier. And by the way, Addie, your suggestion of finding total time of flight, that all works, but they gave me a time. How could I use that? What would tell me? Yeah. I'll find VY final again. In fact, you know what? You guys don't need, I've turned the page, so I'm very quickly just going to go horizontal, vertical, AX is 0, AY is negative 9.8, VX, I got to retranscribe the information. What was it? 30.098. And VY initial was, what was it? 82.693. This time is 12. Why don't I find VY final again? Which is going to be V initial plus AT. Now, I have a feeling, because 12 seconds is a pretty long time, I have a feeling it's on its way down. Let's prove it. It's going to be 82.693 plus negative 9.8 times 12. By the way, if you're really lazy and you were trying to just quickly do this in your head, negative 9.8, what's a nice round number that's really close to? See, I would have gone negative 10 times 12 is negative 120. My initial velocity was positive 82. My final velocity is negative 100. That is negative 120. It's going to be 82 minus 120. It's negative. If you really want to go fast and just draw your picture right away, but you know what? Since you're going to crunch the number anyways, it's not that big a time saver. It's just nerdly cool. Negative 34.907. Which means I think it's going to look like that. It's going down. Where this is going to be 30.098. And this is going to be 34.907. Mr. Dueck, isn't it negative? I've got the arrow pointing down. That contains the negative. I wouldn't take marks off if you put a negative, but I would argue, again, Quinn, technically, if you put a negative and down, negative down is technically up. Technically. Good, solve this. I'll do it up here. Let's see if we get the same answer. So here's the velocity you want to find. Gesundheit. I solved it showing no work, and I would never do that on a test, Justin. But just to show you that, yeah, I got a good calculator, sorry, but I got a good calculator. I was able to do the Pythagoras all in one fell swoop. You can see And I just did Shift-Tan all in one fell swoop. In your homework, if you want to do it that quick, Jordan, go ahead. And then make sure you got it right. If you got it wrong, you'll know, oh, I better write more stuff down. And again, Isaac, on a test, you always, show work and write stuff down because you don't want to make a dumb mistake. But yeah, become expert in your homework. Make your mistakes then. Am I right? Is it 46.1 meters per second at 49.2 degrees below the horizontal? Now, why wasn't this too much work? Because I gave you time. And as I've said to you, if they give you the time, telling you, question's going to fall apart. What if they don't? I like this question, I like this question, I like this question. This time, we're hitting a wall. Oh, I hit the wall a long time ago, Mr. Dueck. No. We're in the physics here. It says this: with what final velocity, magnitude and direction, does the projectile hit the wall? Is there a projectile? Is there a projectile? I'm going to do a T-table. Is there a slanty velocity? Components. Did they give me the time? Did they give me a displacement? Horizontal or vertical? That's how I'll find time. See how, I mean, there's a series of dominoes that occurred there, but hopefully nothing I just said was all that outlandish or new. It was, oh, okay. So, come on, pen, here we go. Let's go horizontal, vertical. Let's put all my data over here. Oh, I can do this right away. In the interest of time, no pun intended, I'm just going to go, I know Vx is going to be 26 cos 37. Which is going to be 20.765. And I know that Vy initial is going to be 26 sine 37, because Vy is sine. And also, we just did it a couple of times. Which is going to be 26. Oh, geez, Dueck. Got to make fun of Rob. Use your advanced features. 15.647. What else did we say? Did they tell us time? No. Did they give us a displacement? Which one? Horizontal. Which column do I have 3 pieces of information in? Horizontal. How am I going to find time? Horizontal. So I'm going to make a little note here. T equals question mark. I'm going to say to myself, I'm looking for an equation that's got acceleration, velocity, distance, and time in it. Have you noticed, no matter whether you're doing it horizontally or vertically, to find time, we're primarily using d equals VIT plus a half AT squared. Ah, but this one's a little nicer. Why don't I need to write the plus a half AT squared? More specific.
The horizontal acceleration is 0.
And so that means this ain't a quadratic. Oh, I won't do this to you, but I know one year as a scholarship question, they gave this distance, which meant you had to solve the yeah. I'm not going to do that. Oh, so if I hear you correctly, and I think I do, you're saying time is just going to be the distance divided by, it's going to be 40 divided by 20.765. You know what? I'm going to get that answer back on my calculator. There's the 20.764523. I just quickly typed in 26 cos 37, and now I'm going to go 40 divided by answer. Why'd you do that? Because he can't. Okay. 1.9264. You know what, Mr. Dueck, let's do this. I need more room. That worked well. Haha. 1.92, what did I say it was? 6.4? Why does that help? I got time. How does that help? Okay. So the most common mistake that I see, by the way, kids do this, and they're so proud. It's heartbreaking. They write down the T-table. Lovely, Riley, lovely. They find VI and VY initial and VX. Lovely. They find time. Beautiful. And then they go like this. They look at the picture, and they say, well, it looks like it's heading down, so they draw this, and that's great. Don't write this down. They put a little V there, Isaac, and they're so proud. They're so proud. They've done. They've got it. They've got it. And they go like this. And they say VX 20.765, and they go VY 15.647. They put the initial velocity there. And then they do the Pythagoras. And you know when they do the Pythagoras, you know what they get? 26 meters per second. And then they do the theta, the angle. And you know what they get for the angle? 37 degrees. How do I know? Because that's where those numbers came from. What they've really just found is where we started from. Don't do that. This is all good. You can write all of that down except for that. We need to find how fast it's heading downwards. And I'm going to assume, Fayez, that the picture is not misleading, that it is heading downwards. And how will I confirm that? When I find VY final, what will it be? Negative. If it ended up being positive, I would say, Dueck, you made up bad numbers. Or Dueck, you yoinked this diagram for somewhere. Well, it's surprisingly a trickier diagram to make than you realize. Anyways. So, VY final equals, oh yeah, V initial plus AT. It's going to be 15.647 plus negative 9.8 times 1.9264 blah, 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 blah. 15.647 plus negative 9.8 times, haha, answer button. Negative. Yes. I get 3.231. 3.231. And do you see what we just did? Tamara, we turned this question into this question. Here I gave you time. And once we had time, it was Pythagoras and Math 10. Okay, the extra step was I had to find time. But now I would argue that that diagram and this diagram are looking really similar. So now what? Pythagoras, and I think it's going to be tangent yet again. V, I'll call it V imp for impact because that's what it's hitting the wall at, is going to be 3. Oh, I got it on here. Answer button squared plus 20.765 squared equals square root of that 21.0 meters per second at opposite, adjacent. I think it's going to be shift 10. 3.231 divided by 20.765. 8.84? 8.8 degrees, is that right? Yeah. 8.8 degrees below the horizontal. Ta-da! Yay! Hooray! I think I've told you I love Foxtrot, so you can read that if you want. The nice thing is the physics in there is correct. Although he's using g of 10 meters per second squared, which is, in a pinch, that works fine. You'll be accurate to a sig figure too, which is pretty good still if you're doing math in your head. What's your homework? We are done the unit. We pause for a second.